These are the notes for video 6, and it's target 5-8, which says I can determine if two figures are congruent, and target 5-9 says I can determine if two figures are similar. So we'll be answering two essential questions today. How do I determine if figures are congruent, and how do I determine if figures are similar? The first term we're going to look at is congruent, and congruent figures are equal in both size and shape. So really it just means that we have two figures that are the same size and the same shape. So our first example is a rectangle here. So I can just duplicate this rectangle and notice that I have another rectangle that's the exact same size, exact same shape. That means they are congruent. They're the same. Okay. Then what we're going to talk about is similar figures. So this is our focus for this video, and it just means that similar figures are equal in shape, but have different sizes. So same shape, just different size. And their sides are proportional. So here's what we mean by that. If again, I just duplicate this rectangle, those two rectangles are congruent because they're the exact same size, exact same shape. Now, if I change this rectangle and I just drag it and make it a little larger, notice that it's now the same shape as it originally was, but the size has changed. And then what we'd have to do is we'd have to make sure and check the side lengths to see if they're proportional. Now, as we look at similar figures, they have corresponding side lengths. So, for example, this rectangle has a short side and a longer side. The short side is, like for example, on the left there, and that will correspond with the short side on the larger rectangle there. Then I have the longer side on each rectangle, and so I can show the difference between those by just putting these little marks on the sides to show that if it has one mark on it, then that's the short side on each rectangle, and if it has two marks on it, that represents the longer side on each rectangle. And so we're going to be doing that today too. So again, these two rectangles are similar. So let's go back to what congruent means. Congruent means that it's the same size and the same shape. So how can I determine if two figures are congruent? Well, right now I look at these two triangles and it appears that they're both triangles and they look the same. They're both obtuse triangle. We have this obtuse angle right there and right there. But what I do want to do is I want to make sure that the sides are the same. So the side lengths are the exact same. So in order to do that, like what we did earlier, or what I just did with the rectangles, is I'm gonna mark the side lengths to make sure that they match up. So let's first call this triangle A and the yellow one triangle B, so I know what I'm talking about. So in triangle A, the smallest side length is 6 centimeters. So I'm going to put one mark on that side length. Now I'm going to go to triangle B. I'm also going to put a mark on the smallest side length, which is 6. Notice those are the same, okay, 6 and 6, so they match up. Now I'm going to go back to triangle A, and the largest side is 13. So I'm going to put 2 marks on that one. Now I'm going to go to triangle B, and the largest side length there is also 13 centimeters. So I'm going to put 2 little marks on that side length. And again, notice that they're equal, they're the same. So the last side length to check, if I go to triangle A, the middle side length is 8 centimeters. So maybe I put 3 lines on that side. Now go to triangle B, and I notice the middle side length is also 8 centimeters. And so I'm going to put 3 lines there. Notice that 6 and 6 are the same. 8 and 8 are the exact same. And 13 and 13, they're the exact same. Which tells me that these two figures are congruent. Okay, they're both obtuse triangles. They have the exact same side lengths, so same shape, so they're congruent. So down here, when you fill in the blank, we can say they are congruent because they are the same shape and size. They're the exact same. So that's what congruent means. Now in this next section, we're going to focus on what it means to be similar and how do we know if two shapes are actually similar. So if you look at your essential question, it says, how can I determine if two shapes are similar? Well, here's our first example. We have two parallelograms. So again, I'm going to call this parallelogram A and this parallelogram B. So let's mark the smallest side on each parallelogram. So 12 and 4, I'm going to put one line on each of those sides because they're the smallest sides on each parallelogram. And then the longest side is 15 centimeters. So I'm going to go to parallelogram A and put 2 lines on the 15 centimeter side length. And then I'm going to go to parallelogram B. The longest side over here is 5 centimeters. So I'm going to put 2 marks on that side. So now I have 2 parallelograms. They look like they're the same shape, just different sizes. One looks larger, one looks smaller. The next thing to check is, are the side lengths proportional? So in order to check that, we're going to set up a proportion box. And if you look at your first step then, what 2 things are we comparing here? What we're really comparing is we have parallelogram A and we have parallelogram B. So now I'm going to take one of the side lengths from A. So let's start with the smallest side length, which is 12 centimeters. And that had 1 mark on it, so I might even make myself a little note up here and just put 1 mark there. So now I'm going to go to rectangle B, and I need to find the smallest side length there. It also had one little tick mark on it. And so that would be the side that is 4 centimeters long. So now let's go back to parallelogram A. And the longest side length is 15 centimeters. And again, I might just make myself a little note there to say that now I'm going to record the side lengths that have 2 little marks on them. And so from parallelogram A, that side is 15 centimeters long. And from parallelogram B, that side is 5 centimeters long. So here's my proportion box. Now I have to determine if these ratios are equivalent. Well, we've already done that, so you guys should be familiar with this. What I'm doing is I'm comparing this ratio, 12 to 4. I want to know, is it equal to 15 to 5? We have a couple ways to do that. One thing that I notice right away is that if I take the denominator 4 and I multiply it by 3, I get the numerator 12. The same is true if I do the denominator 5 times 3, I'll get the numerator 15. So since I'm multiplying each of the denominators by 3 to get my numerator, then yes, I would say these ratios are equal. Another thing that you can do is you can simplify them. So I have the ratio 12 to 4. If I divide each term by 4, I'm going to get the ratio 3 to 1. If I have the ratio 15 to 5, I can divide each term by 5 and get 3 to 1. Again, notice I get the same answer, which means they're equivalent. Another method we talked about was, well, let's change each of these to decimal numbers, or in this case, a whole number. If I do 12 divided by 4, I get 3. And over here, if I do 15 divided by 5, I also get 3. Again, I'm getting the same answer, which means they're equivalent. Then another method we talked about was cross products. And remember, when we have cross products, that means I'm going to do 12 times 5, which is 60. And then I'm going to multiply diagonally over here, 4 times 15, which is also 60. Again, just another way to check to see if they're equal. So yes, these 2 figures are similar. They're similar because they are the same shape, different size, and they are proportional. that's what makes two figures similar. So for our last example, we have two triangles. Again, what I'm going to do is call this one A and call this one B so I know which one I'm talking about. Then if I'm going to set up a proportion box, I'm going to put my labels here. I'm comparing A to B. Now again, I see two triangles. It is an obtuse triangle. I see one obtuse angle in each one. They appear to look very similar. So now I just need to check to see if they're proportional or not. So now what I'm going to do again is I'm going to put those marks on the triangle so I know which sides correspond, which ones are going to go together. So let's look at triangle A. The smallest side length is 12 centimeters. So I'm going to go to triangle B, and the smallest side length is 3 centimeters. So I'm going to put one mark on each of those sides, so those go together. Then let's look at the biggest side, the longest side on triangle A, and that's 24 centimeters. On triangle B, the longest side length is 5 centimeters. Now I know the picture isn't very accurate. What you want to do, pictures can be deceiving, so always look at the actual measurements that are given. And then finally, the medium side length is 18 on triangle A, so I'll give that 3 lines. And then the middle side length on triangle B is 4 centimeters, so I'll put 3 little lines there. So I'm going to set up my proportion box. So let's say I want to look at the smallest side length, which I put 1 little mark on that. So from triangle A, that would be 12 centimeters. And from triangle B, that would be 3 centimeters. Now I'm going to look at triangle A again. Let's pick the largest side, which was 24. So I'm going to pick the side that had 2 marks on it. Again, I might just kind of make a note for myself up there. And that would be, 24 from triangle A and 5 centimeters from triangle B. So now I just have to see if these two ratios are equivalent to check for proportionality. So right away, I noticed that 12 times 2 is 24, but if I were to do 3 times 2, I would get 6, not 5. So that right there tells me that this is not proportional, which means these figures are not similar. So these triangles are not similar. So they're both triangles, so they're the same shape, different size, but when we check the sides for proportionality, we notice that they don't form a proportion, so they can't be similar. They can't truly be similar. We have another proportion box here because just to show you that I can compare A to B, and maybe I use the smallest side lengths again, which are 12 and 3, but now maybe instead of the largest side, maybe I pick the medium side. So the one with 3 tick marks on it. So from triangle A, that would be the 18 centimeters. From triangle B, that would be the 4 centimeters. And then again, you could do anything. You could do 12 divided by 3 and 18 divided by 4 and see if you get the same answer. You could cross multiply 12 times 4, 18 times 3, see if you get the same answer. You could take the ratio 12 to 3 and simplify it. You would actually get 4 to 1. And you could also take the ratio 18 to 4, simplify it. You're going to get 9 to 2. So either way, any method you use, you're not going to get the same ratios. And so again, these ratios are not similar because they are not proportional. And we just showed you here that there are multiple ways to check for that. Now finally, what you're going to do is you're going to write your summary. And you're going to start by writing, today I learned, and remember that there were 2 concepts. What does it mean to be congruent, and what does it mean to be similar? So just keep both of those things in mind as you write your summary.